So, good afternoon, everyone. We now continue with our discussion on this book. So I think the last time we met, we were discussing types of machine learning. I think we said there were various types, continuing from where Shamu stopped. So that the classes of the classes or categories of machine learning could be divided based on how they are supervised, whether or not they can learn incrementally on the fly, and whether or not they can work by simply comparing new data points to known data points. So the first one, and everyone can comment and interrupt, and it's a discussion, like we've said. So based on how they are supervised, so there is supervised learning, there is unsupervised, there is semi-supervised, then there is there's self-supervised. I think we covered this last time, right?
This way we stop, I believe,
Okay.
class of machine learning. But we just briefly talked about this thing. But I think these types of machine learning, I think is basically that's what is basically talking about.
Yeah. So basically, the supervised class, it just it uses labeled data sets to train the algorithm. So, but the unsupervised does the opposite. Doesn't use any labeled data set. It just recognizes patterns. If I'm wrong, correct me. Shawo.
Yeah. That's it.
So semi-supervised is in between that. In between that, I saw someone talking about, hey, where is okay, he's not here. He was supposed to give us like a briefing on his paper. I would have easily started with that.
Yeah,
It's okay. Maybe at the end if he comes. So another one is whether or not they can learn incrementally on the fly. So Shamu talked about this an automation sort of thing. Like online, it means that at every given point, the algorithm, the machine learning algorithm, can consider new data inputs, and tune the model accordingly. For batch learning, it's just so batch learning means it's not online. It's just by batch. So you train now, you gather inputs over some time, and then you use the input to train again to tune it, and then you gather after some time, you use it to. So it's by batch by batch. Oh, Shamu.
Yeah.
Yeah. So, and then whether they work by simply comparing new data points to known data points, or instead by detecting patterns in training data and building a predictive model, much like scientists do. So machine learning systems can also be instance based or model based.
Yeah.
Yeah. You have any comments on that?
No comment on that. I think instance based is okay. Let me just, I think maybe it's something like, or let me talk about the instance based. Instance based is just like maybe you collect your data points, then you do maybe comparison between all the data points to figure out which label you give to that new data. Like if you have new data point now, let's say maybe you are classifying something as a cat now.
Yes.
Like whether cats, dogs, or maybe a cow now. Then if you collect new data points, now you are definitely getting the features. So now it's going to take that data, the features you have for that data, but it's going to compare it with
the new data
the data points you've had before.
Yes,
It's going to compare them with
the
them.
new one.
Then based on the closest class, it's going to categorize that. That's what instance this modeling is. Then the other one model is when you actually build like a model. that one, it has a fixed function that actually gets the input and predict the output.
So, and this is a very important point, I think, that the criteria are not exclusive and they can be combined in any way. So, for
Yeah, yeah.
example, a state-of-the-art spam filter may learn on the fly using a deep learning neural network model trained using human-provided examples of spam and ham. This makes it an online model-based supervised. So you can see you're combining all of them across. But it cannot be supervised and unsupervised at the same time. It cannot be completely supervised and completely unsupervised.
It can be actually.
Completely supervised and completely unsupervised.
Okay, you can actually mix both.
Yeah,
It
that's
can
for
be.
semi-supervised,
It
right?
can be. Yeah, it's
Semi-supervised.
actually, but it's just all this stuff about like most state-of-the-art models number. You
Yeah.
have like you can combine more than one model. You can have 3 to 5 models. Maybe the first part of the model will be doing unsupervised, then the second part might be a supervised learning algorithm, all this stuff. So you
Yeah, so
can
that's what I'm saying. That it cannot be completely supervised and completely unsupervised.
it can be completely supervised and it can be completely unsupervised.
No. I mean, in exactly the same, like a model. Oh, we take
Okay,
one single model.
in semi, right?
Yes.
Okay, yeah, sorry, yeah, yeah.
Of course, it doesn't make any sense. That all your data points are labeled and they are at the same time unlabeled. Doesn't make
Yeah,
sense. Yeah.
yeah.
So what I'm saying is that you can combine across.
Yeah, you can combine
Uh,
across.
So training supervision. Shamu, please go on.
Yeah, do you check on maybe like these other guys, maybe Abdurrahman and stuff? I think he was here with you the last time. And
You see, go. Really,
yeah,
forgive me, but gaskiya we cannot continue to spoon feed people.
no, I like maybe I don't know.
See,
Yeah, I
if
get, I
something is
get, I get.
important, if it's important to anybody, they should just try and take cognizance, put alarm or something.
Yeah.
He asked now. He was the one that asked. It was Abdraman who asked last time whether we are going to have the meeting, and I said yes. So he should have been the
Okay.
first person to be here, I think.
Yeah, because even the other time, Roji later called
He
me
called
that
me also. He called me
yeah, he
also.
called me.
But see, today we have the same situation.
Yeah, I messaged him just like a couple minutes back now, and I just checked my WeChat now. He has responded. So like asking for link, and I don't think I even have the link for this
I think it's
meeting.
in the group.
You sure? I don't
Of
think
course, it's in the group. It's even.
No, this I don't
this link.
think this meeting
This
is in the group.
is
it
not in
is.
the group.
It is in the group. It's in the
You
group.
sure? It isn't. I
Of
just
course,
this
it's in the
one.
group.
I joined asking, Charlie give me this. I don't know.
Let
Maybe
me
I
let me
missed it
let me
this
show you.
thing.
The link is in the group. The
It's in the
link
group,
is
of
in the
course.
group.
Okay. Yeah, I think I can. This thing.
I'll reshare it, but it's in the group. It's not only in the group. I did this shout out. Shout out.
Ali, maybe can you hear me?
Stick on. I did stick on top. Stick on top.
Ali,
Yes.
Oh,
maybe if you can make it like if you can put the
and
link
they
in
wait
the
me.
group notice.
It's in the group. Okay. The link in the group notice. I think
Yeah.
it is. Just check. I think
I don't think it is
It just comes.
in
It
the group
just
notice.
is.
it is.
It is actually.
Right? Okay. It's
Yeah,
not.
it
It's
is.
not in the group notice.
Mm-hmm.
So yeah, like I think that's that. Then we talk. I think maybe we should just scroll down there and go through the examples of all these supervised and unsupervised tests.
Yes. Training supervision. Go on, Jamal.
Yeah, training. How do I control the screen? Or
Okay. Just share your own.
okay.
Let's do it like that. Share yours. Let me. Okay, sure. Yes, you can share your own. Brown, welcome. Welcome.
Yeah,
We
wait.
can hear you.
Yes, we can hear you, sir.
Thank you.
Someone please
You're
share your
welcome,
screen.
sir.
Yeah, sorry.
And I want to say that we really will not wait for anybody.
Yeah, I guess.
We're not going to. Yes, you see, we started almost immediately. If not because Charlie had some issue with his microphone. We're not going to wait for anybody. And please don't expect that we'll call to remind you.
Let's just drop message inside the group, then like we follow up with.
Yes. Yes. We're on this in second page.
Yeah,
The-
types of machine learning now.
Yeah,
So let's talk about the
training supervision. Yeah.
So supervision, like the first one, like Ali has already given like a summary of what we talked about in the last testing. So the first one is like supervised learning. In supervised learning, we actually have like we collect data, then each data point they are tagged with their label. So example is like something like a fruit. If you collect fruit now, if you are like maybe trying to classify fruit now, you can collect like maybe the color of the fruits, maybe they have seed. Those are what we call features. Then after that, now you take that, those features now you tag it with a label, like maybe orange now, let's say, okay, maybe I shouldn't use orange because we have like some oranges that maybe yellow and all this kind of stuff, but we can still collect that sharp. You can have orange, maybe the color is green, there is seed, is juicy and all this kind of, so we tag that one orange. All these features, color, juicy, and seeds, they are the features. Then orange, that's the label. Those are the kind of, so those are the data points those are the kind of data we collect in supervised learning. Each of the each data point, they have labels. And that's what we use in training in supervised learning. And actually supervised learning, they are actually divided into two. We have the classification task. Classification task is when we are actually making classification, like we are putting data points, predicting data points into different categories, like maybe orange, maybe like something like fruits. Those are classification. We predict in categories. But in regression task, the other one is regression task. We are actually dealing with numerical values. Like maybe I'm predicting your age. We are dealing with continuous data here. In the regression, maybe I'm predicting your age. We are predicting the price of something. Those are regression tasks. Classification tasks, we are predicting data into labels. And we have unsupervised learning. Those are the two categories of supervised learning. Then unsupervised learning, we have data, but we do not have labels.
Sorry, Shaun. Sorry, I just want to remind everybody that you can always interject. It's a discussion.
Yeah,
You can always talk, always. I just want to remind people about that. Let's go on.
So that's what unsupervised learning is. You have your data points, but they are not actually labeled. Example is like maybe in Walmart now, they can collect data of all the sales they make. Then if they have that data point, they can do like a maybe clustering analysis. In clustering analysis, what they do is actually they collect the data points, they are not labeled, then they use clustering, like an unsupervised model, which is like maybe like a clustering type now. Then they use it to put those data distance for each sales they make now. They separate it into like clusters. They can make 3 clusters, they can make 4 clusters. So what the algorithm does is to find patterns in the data, then clustered the data into different sections. Maybe the first cluster might be like people that are rich, that they buy expensive, they spend money. The second cluster might be like average people, they spend averagely. Then the top people, like they just buy like cheap stuff and other stuff. If they have that, they can actually use that to drive their marketing strategy, create marketing plans and all this stuff. So that's what clustering. That's an example of an unsupervised learning, clustering. Another type is dimensionality reduction. In dimensionality reduction, what they do is another example of unsupervised learning. What they do is actually when you collect data points, the data points you collect might actually have like maybe 1,000 features. And if you have 1,000 features, it's very difficult for algorithm or any machine this thing to learn it. Even if it is going to learn to a certain degree, but it can't be as efficient as you having like a small features, like important features, small important features that can actually explain the variation in all the data points. So dimensionality reduction is if you have like maybe 1,000 features, you can compress those features into maybe like just 10. You are going to do dimensionality reduction. You compare it from maybe 1,000 dimensional distance space to maybe 10-dimensional space. That's what dimensionality reduction, and it's also an unsupervised learning algorithm or type of machine learning. And there is this one too, anomaly detection. When you collect data, you can actually use unsupervised learning to detect if some of the data points, they are actually outliers or they do not belong into that data points you collect. Let's say we are collecting like ages of people in maybe in our class now, then we know like majority of us now, we are maybe around maybe 20 to 30 years old. But just from out of nowhere, you see someone with maybe 40 years of age. So now that's like an anomaly. It's like an outlier. Like you can use like machine learning this thing. You can build an unsupervised learning to detect that. Like if you build this thing, you can detect that, okay, this 40 is like, this is out of the, this thing is out of the points you should have, and you can have it something like that. Then we can have, those are the three, these are just some of the types of unsupervised machine learning this thing. So in supervised machine learning, we talk about classification tasks and regression tasks. Yeah, unsupervised learning, we talk about like, this is, the first one is clustering. You take data points, then you put them into different clusters. You separate them into different clusters. The second one is dimensionality reduction. Like maybe from 100 higher dimensional space, you put them to lower dimensional space, maybe like 1,000 dimensional distance, then you take them to lower dimensional distance by extracting like the important parts, important features out of that higher dimensional distance. Then you put it into the lower dimensional distance. Then anomaly detection is when you build an unsupervised machine learning system to detect like maybe outliers in your data points. Then this is semi-supervised learning. In semi-supervised learning, or what we do, we collect data. Some data points are labeled, some are not. And I think I have one this thing on my phone, on my Samsung phone I'm using. I have one great example of it is they use it on the Samsung phone where if you snap images, you can tag them. You can tag images. Maybe if you go to your images now, you go to your picture now, then you can add tag. If you add tag now, if I say, okay, if I go to your picture now, I go and create this thing. I select your picture now. I say, okay, this is Aliu. I go to another picture now. Like, okay, this is mom. I go to another picture now. This is dad.
Just to protect the interest of iPhone users, we also have it.
Okay, okay, okay. Yeah, don't worry. I'm using iPhone too. So you can have that, but so when you want to create this thing now, so the system now is now going to learn all the distance because there are different images there, and this algorithm will learn like this particular person, this is who this person is. You just need to tag like just few images because you have like maybe you can have like 1,000 images in your distance. You just tag like maybe 1 or 2 pictures. So from there, the system will like, so the next time you go there, you type mom. If you go to the site, if you type mom, it's going to bring all the images where your mom is in that particular distance. That's an example of semi-supervised learning.
I know, Shamo, I want to add on this semi-supervised. There's this Muhammad Amin. He's working on crack detection.
Okay.
So he did something. He proposed a method based on semi-supervised learning, and at the end of the day, one of his strong points was that he needed comparatively less data, to make very good predictions than unsupervised.
Yeah. Okay.
Yeah, and that was one of his major points that got the paper published. So, and this is one critical point that we can add to our baskets of the derivables.
Yeah.
That's what I want to add.
Yeah, I think
You'll obviously need less data, right?
you obviously need less
Yeah.
data. you compare to other this thing.
Yeah.
So and there's self-supervised learning. So in self-supervised learning, actually, an example is of this image now. What you actually learn is you get what you actually learn by is now you are not is actually a type of machine learning where you actually learn the same kind of something. Your input might actually be your output. An example of this image now, you can just collect like images now, but you can just put a mask on this like this now. This you put a mask on this thing. Now you are going to this image will serve as your input, and this image will serve as your output. So the function of this system now will be to what generate like an original image when you give it like maybe a masked image, a blurry image, and this what they use this in like image reconstruction. Actually, funny thing is that we are actually arguing about this yesterday. Like if you have a blurred image, you cannot. Oh, okay. Actually, someone was arguing that if you have like an image that has already been distorted, you cannot actually regenerate the original image. But we were arguing that you can do that, and just fortunately, I saw this while I was going through this thing. So this is just an example of self this thing. Your input will be like this image, then this thing. Your output will be like the original image. You just put a mask on the image, then you learn the system learns figures out the patterns and the function that can map that original mask data into the original data points. And this is what they use in image like reconstruction. There are like some apps that you can actually use to generate background. If you remove background, like say you have like if you remove background, like some part of the background, if you input your image into that this thing, you can actually generate like the background you remove from that this thing. This is an example of self-supervised learning. And we have reinforcement learning.
Can I?
Yeah.
Yeah. I want to emphasize to members that understanding the concepts behind these methods is I think is the most important. You know why? Because you have a problem, like choosing the approach to solving the problem can be a nightmare. So
Yeah.
the fundamentals, the fundamental concepts of some of these things are really matter more than sometimes even the skill of coding. Because if you choose the wrong method, you end up wasting your time. Or the wrong approach.
Yeah, exactly. I think understanding the problem is the most important this thing. And it's actually one of this thing. Like there's what we call like life cycle of a machine learning system. Scoping is the most important thing. Like that's where you get to understand your problem. Because if you have a machine learning problem, there are various ways, like methods, like things you can think of ways to actually solve this thing. But choosing the right one is the most important thing. You understand the problem, then you find out, like if you choose this particular method, you check out the feasibility. Is this possible and all this kind of stuff. You try different this thing, like just check the feasibility of different methods you want to use. Check it, then you can, before you actually choose, okay, this is what I want to do and stuff. And the concept is very important, and like you just mentioned. Like I said,
Yes. We're still here. We're listening.
We are here.
anyone has anything to add before I
I don't know why people are not engaging us as engaging as the last time we did the meeting. I don't know. Is it that we are not getting it? The aim of this thing is not to cover many pages. So
Yeah, it's just to
really
understand.
So we can go back. No problem.
Because at the end of the day, maybe at the end of the day, if we come up to later this thing, now we still have to refer back to all these concepts.
Yes.
Getting all this stuff now, you can refer back to it and okay, this is what this is what this is.
Yes. Please feel free. Please feel free to comment, interject, ask. Just feel.
All right.
Rosie,
This
welcome.
more, he's not sleeping today. I think that's more like this thing. We can actually have this chat. We can go through this. I believe all of us have this thing. We can actually go through it.
Yeah, it will
we
help
have,
us if we go through it before we even.
yeah, we
Full
even
fully
have,
yes, yes. That's
yeah,
it.
better understanding. And I think maybe if we go through it, then points that are not clear, we can just bring
can
it out,
even
then
have,
discuss it,
Yes.
discuss it together and iron everything out.
Yes.
Then reinforcement learning. Oh, actually, this is another this thing. This one too, like this how they actually, this is the kind of learning they use for like all these, oh,
optimal control of the body.
optimal control,
control.
robots,
Yeah.
self-driving stuff like that. What they actually do when they are training the system gets to make the decisions. Then based on the decisions it makes, they at that point, if it makes the right decision, you reward the system. If it makes the wrong decision, you punish the system. And at the end of the day, the most important thing is for the system to generate what we call a policy. The policy is like when you are what the policy does, what the policy is that you have like a mapped instructions of how the system is. If you are in this particular scenario, what is the right action to do? That's what the policy is. That's the goal of this thing, is to generate a policy that, okay, if the weather is cold, if the weather is cold, what should I do? That kind of stuff. Okay, yeah, take hot tea and all this kind of stuff.
Yeah, and this, how you train dogs. Like if for example, it works like a reward system.
Yeah,
Yes, reward and
Yeah,
punishment
yeah.
system.
yeah,
For animals, for example, if he does the right thing, maybe you give him what he likes. It like
yeah,
like dogs, maybe
yeah,
some foods,
yeah,
or
exactly.
if it does this, then you give it some bonus. Then it recognizes that, okay, what is done, what it has just done is correct.
Yeah, that's how we are even trained as humans.
Yeah.
Like if you do something wrong, our parents will come you, slap you, and all this kind of stuff. So if you do something decent, they reward you
I
and
have
all this
some
kind of stuff.
disagreement with that, but this is not the forum.
Okay, no, you can let's
No, this is not the
discuss it.
forum. This is not the forum. It's long because it's people who are not beaten.
Okay. No, you don't actually. I don't actually. Okay, me. That's how my own system.
That's entirely
That's
another
punishment,
Dogs
but
or something.
that's
All these
punishment can be.
very highly trained dogs.
Yeah,
Is you use the concept of reinforcement learning. You
yeah,
create a reward system to make it learn what is correct and what is not correct.
yeah.
And
I
this
think,
what is correct and what is not correct is subjective. It's subjective.
Yeah, it's subjective. I think it depends on the distance. Like I don't all this stuff, but there are no general rules for. That's what I actually be like. There is no particular. There is no like. How do I say it? Like this particular stuff works, then it works for all situations. If you have like a particular system that works, it doesn't work for like the entire situation. You have like a scenario where that particular system will fail. So the idea of what's good and what's bad, it depends on the person actually programming it and building the system. Because like in the maybe like all other foreign countries now, maybe they don't beat their this thing. Because if you even beat your child now, that's like a form of child abuse. You see them like grounding their children, like you can't go out, seizing their phone and all this kind of stuff. So that's how they say like what reward is this, what punishment is, and kind of stuff. But at the end of the day, reinforcement learning is just based on reward and punishment system where you train your system. So, and these are like we have like different stuff. We have the agent. The agent is what you are training, and then the environment is environment. So the first thing if you have an agent is to observe. The agent will observe the environment, then it's going to select an action using the policy. The policy that's already built is going to take that action. If you get it right, you get reward. If you get it wrong, you get penalized. Then if you get penalized, then you have to update the policy you use in taking. So if you get it wrong now, you know that, okay, this is not the right action now. Then you update it in your distance. Then you iterate until an optimal policy is formed. This is what you do till you get like a very good policy. That's all about reinforcement learning and stuff like that. Then we have another class actually.
Jamu,
Sorry, I have a question.
Yeah, that's one. Yeah, I'm listening.
Ask away.
We can hear you. We can hear you. I'll use Faisal's one. Let's say.
Yeah, that's what I'm doing. I'm doing now.
Mission so you did.
What happens when, let's say, you have a policy, right?
Yes.
Like let's use this fire and water policy.
Scroll up small.
Now you have this the first time he touches the fire and then it hurts him. It updates his policy, right? The learning
Yes.
step.
Yes.
What happens when there is a scenario where it needs that fire to do something? Will it use the fire away to avoid the fire?
Like the entire system,
Oh.
boys, it depends on the system you are building. If your system is it depends on the system you are building. I think like it depends on the data you feed the system. Maybe in a particular scenario now, if this happens, you do not do this. If this happens, you do this. So the system is going to decide based on that. If it has learned if it has an optimum policy, it's going to decide based on that, based on the policy. And these systems they are not 100% this thing. So will be like a scenario where they crash and they make mistakes and all this stuff.
All right.
So we have like batch versus online learning. In batch teaching, what we actually do is we collect data points for sometimes, then we make before we make prediction. Before we train the system, then in our system, we have to collect data for some time, then before we make prediction. Whereas in online learning, once we collect our data, we predict right away. We don't wait for like this thing. We don't gather data for a while before we make prediction. Once you get the prediction, you just make your prediction, right? An example of this, they use it in like all this forecasting, like all these time series analysis, cryptocurrency and all this stuff. That's what they actually, because all this stuff they are, I don't know. They learn incrementally, in short. They learn incrementally once you get it, this thing. And the system is also being trained like that. So for every data point the system gets, it automatically updates. It learns from that data point. And once you learn from that data point, some systems, they can still keep those data points, maybe for later, or if you like, you can just discard the data. Once you get the data, you discard it. And in online learning, this actually saves like storage, because you don't actually have to store that data points. That's if you choose not to store the data, the data you are getting. But in batch learning, you have to store the data. That's like another this thing. And this batch learning, actually, most of the systems are actually mostly trained on like offline. Offline, like you just have to sit down on your system, then you collect this thing, then before you make predictions. But online system, you train it they learn on the fly. So once you get the data, you just predict, then you go. Predict, you go. So I think that's just like this is just on the image of the online learning system where you new data on you will just predict on the fly. But you have to train the system, or you train the system first. Then once you launch it, as new data points is coming in, then it will adjust the model you've already trained. It's going to adjust, like maybe based on new data you see now, you adjust some maybe parameters from the already trained model, then you discard the data, you discard it. Once you get the data, you discard it.
Now, you talked about some of the advantages of this online learning
Yeah.
over the batch learning. For example, you don't have to store the data.
Yes.
It learns on the fly. But for batch learning, it's usually done online. So you gather data and then before you fine tune.
Yes.
So I'm sure there are advantages of the batch
learning over online.
Yeah. For example, maybe I'm not sure. Well, maybe pre-processing issues.
Actually,
because in the online you automate the pre-processing also.
Yeah,
Or
in the in general, actually, I think the preprocessing is not actually an issue in online and batch learning system, because even in
no, no,
online system,
in
yeah,
online.
in online it's not actually a problem, because
Okay.
your system online, actually we have what we call a pipeline just serves like a pipe, then you put all the necessary
All the
steps,
all the filters, everything that you want
yeah, all the necessary process you want the
in the
data
pipeline.
to
So it goes through the pipeline
yeah, it's
before being
yeah,
becoming an input, before
yeah,
being proper. So what I'm saying now is, don't you think that sometimes, for example, where you have unexpected outlier, let me give you an example. Let's say you are monitoring let's say like the vibration of the wheel and rail. Just an example.
yeah,
So all the data you collect will be consistent with the ones you've previously seen. The model has seen some of that, like some of it. So the
yeah,
pipeline is continuously going to work. But now when you have uh, a fracture or failure of the wheel, the frequency is going to increase.
yeah,
So it has not seen that kind of thing before.
that kind of data
So, but
before, yeah,
in
yeah,
batch, you are easily going to see that okay, there is a problem, there's an outlier. So
and
you either
okay,
remove the data or you normalize them or something. But
yeah,
online, you understand? So when it comes to uh so I think in that context, maybe the batch
the
has
batch is
some
better,
advantage. Yeah,
but actually,
that was what I was thinking when I said.
yeah, actually, but like I think that one, but that this thing you just raised up now, that one too, it has already been, it is also it has already been addressed in all these systems, actually. Because at times, when this system, when machine this thing, when this system, the online system is learning from this thing, if you are getting data, I told you, like, it's going to make adjustments on the already system you launch.
We're fine tuning it.
Yeah, it will be fine tuning it. Now, when it receives this data and the model is getting worse, you can actually revert it back to the best model you've had.
Makes sense. Makes sense.
You can revert it back. If the training, if the this thing, the performance is getting worse, then you can revert it back
The
to
best
the
that
to
it was before.
yeah, the
Okay.
best you've
Okay.
and
But how does that
there are
work?
actually some, like, maybe there are some monitoring system they put in for this thing. Maybe if this particular values is
They
going,
continuously evaluate the
yeah,
model.
they continuously evaluate the system so that they keep it this thing.
So you have some. So maybe I'm thinking that you have some threshold. If it's
Yeah, exactly. Something
more
like
than
that.
this,
Threshold. If this is more than this, then the system will raise, like, we raise an alert and all this kind of stuff. You set an alert. So if this particular, maybe the features now,
yes.
because they are okay, I don't think we should be discussing, because there are various problems. Just coding in on your system and doing all this thing is way different from, like, machine learning in the production. Because in production, we have what we call concept drift, data drift. In concept drift, your data can change. Like an example of, let's say, maybe concept
Because
drift
it
is
does the concepts.
yeah,
It's a set of logic.
yeah, it's a sort of, like, your data can entirely change.
Yes.
So if you train a system now and your data changes now, your system will make wrong prediction. So you cannot actually, your system won't be that much reliable.
Data
From
driven.
this.
You know all the data.
Okay, actually, what concept drift is, like, the mapping of your input to output will change.
Okay.
That's what's called
If the data
concept drift.
changes.
But in data drift,
If the data
only
changes. Sorry, I don't understand the first
the
one.
the data, the input data you get, the mapping will change. It means, like, the input data you get will no longer generate, like, it will map to the label you give
So the
it.
concept will change, the logic will change, the rule
Yeah,
will
the
change.
logic will change.
The
But
rule, right?
yeah, the rule will change.
Okay.
Maybe when you get this particular image, this is a dog. But if there is concept drift now, you can get this particular input, then it will now categorize it as a cat. That's the mapping. Like, the input is no more mapping it to the output you had before.
Yes.
Like, maybe, let's say, example is like, maybe if someone becomes famous suddenly now, this person now, if you put it in the system, like, this is a nobody, But if that person, if you put it again now, he's going to say, oh, this is a celebrity now, and that kind of thing. That's like a concept drift.
Then
But
it's data
in data drift, your input is what changes. Only your input will, your input will change. Like example is like maybe like all
remains
this.
the same.
Yeah, the rules will remain the same, but the input will change.
Input changes.
And if you have that problem, it's still going to give. It might give wrong prediction.
Wrong, of course.
It's going to give wrong prediction.
Let me give this scenario now. Sorry for interrupting you.
No. You are supposed to interrupt. Well,
Like, for example, now this railway transportation now.
Yeah.
Like, for example, in China now, whereby they have different like different temperature, different weather in different region,
Yes.
whereby the same railway or the same vehicles travel to this different region. So what's the condition, or how can we categorize this particular scenario, whereby in very, very hot environment, like railway traveling to a very extremely cold environment. So this and this kind of scenario now, like how can we categorize it? For example, maybe
the
like
mapping and all those
all
stuff.
these mapping stuff.
Okay, actually, when we are training a system, a machine learning system, what we actually do about is like in China now, you can build a machine learning system that will perform in the code regions. You can build a machine learning system that will perform independently on this thing, that will only on the hot regions. If you can build a machine learning system that will perform well on both.
Okay.
So now, when you build a machine learning system now, if you build it for African people, you don't expect it to work with the Asian. If you go and launch it in the Asian people, it's going to perform worse. If you want it to work for the Asian people, you have to collect data points of Asian people when you are training the system. So those are the data, you collect those data points, then you train your system. But in reality, things change, data has changed, like everything changed. Like something like if you build a machine learning system now that is like maybe fashion trend or something like that now. Maybe number is fashion that is trending, is this pattern. Before you know it's next year now. But that's what you train your data on. Before you know it now, in 6 months now, another thing is trending. If your model gets this data, it's going to predict it wrongly. So we actually need to, like, maybe from time to time, you retrain your system and relaunch it based on the new data you get. That's what the concept and the data drift, you have to take that into consideration when you are like putting machine learning system in production. So the constant retraining of model is very important in this thing.
But for what do you call it, for academic purposes,
Yeah.
will you consider these concepts?
No. I think academic purposes, most academic this thing is just research. Most academic models, but they don't get to
for production also.
Yeah, they don't actually
Production
get
is
to production.
totally
It's a very totally different this thing. Academic, they even separate themselves, academics and like production this thing. They separate them entirely. Because in your academic system, what most research focus on is the model, how you make your model better. But in this thing, they are model driven, model based type of machine learning. But in production, now they use model before, but now they have to, it's changing to data centric type of system. Like if you can have a you can have a simple machine learning system, then if you clean your data very well, you will get a very good performance. So you can focus your attention on the data, make the data clean the data, make the data as good as possible. Then you can use your model to predict. So in production, like data is like actually like the most part of is, you can say like it's the most important thing, but in research, like the model is like the most important. It's kind of the most important part of the system. I don't know if I answer you.
Yeah, I get.
And I think if I can add a little bit to it, you know, there's a lot to consider, you know, when talking about this kind of problem, you know, each and every machine learning model is different, and also the application area is different. So there's this concept of generalization and robustness of machine learning models. Like in terms of generalization, how well a model performs on new or unseen data, and robustness in terms of perturbation or noise. And
Yeah.
like, yeah.
Yeah.
So I think when we reach to the maybe programming the model, we'll talk about the concept of optimization algorithms.
Yeah. I think
That's
that's
the main use of optimization algorithm in case like when you are applying the model on new data sets, like after training the model, when applying them on new data sets, the main goal of the optimization objective is to minimize the total loss function.
Yeah, it will mean
Yeah,
that's
yeah.
like the most important this thing, but because if you're training,
So I think
it's the most
we'll
important
talk
part of
about
it.
this. Yeah.
Because new data points
Sorry,
is what actually
sorry guys.
matter.
Rosie,
Hmm?
loss function they are talking about, we've not reached there.
Yeah, no. Like
But more the
this
line
problem,
talking.
like I think the problem will be much more clear to us when we reach to place, you know. When we
We
reach to
talk about that like maybe in the later
yeah.
like later sessions.
Please,
Yeah,
please, as we discuss,
but for
guys.
now, the main concept is
Yes.
the generalization and robustness of
The
the models.
system. Yeah.
There are some criteria, or like there are some, for example, in terms of eating, like we'll talk about them. I actually
Okay,
forgot.
let
Yeah,
me
we'll talk
just put
about
it
them.
this
Talk
way,
about
but
them.
let me just yeah. We talk about it later. Let me just put it this way. I think what Ruji is trying to say is like the generalization, how to generalize on data points is like the most important thing. Because actually, when we are training a machine learning system, if you get your training data, what the system learns from is your training data. If you get new data now, the new data will be different from the training data. Your system, your machine learning system you throw on this training data can actually memorize the training data. But when you get read word data, you get new data now. Can your machine system, can it perform well on this new data point? That's the idea of like generalization. So now, when you are training your system model, you can have a performance of 100%. You can have like the system will predict everything. But if it gets new data now, you might be having like a performance of 70%, which is not good. So there is a way like there is a trade-off between that's what they call variance bias trade-off. That we call it bias and variance trade-off. But the most important thing is like if you have a system that is performing, that is giving you 100% accuracy on the training label and 70% accuracy on new data, there is a trade-off you do. You can bring them, if you can bring them down, both accuracy, you can increase this one to the new data is the most important thing. So if you can raise the accuracy of it gets on the new data to maybe that kind 80%, then the training data if you can bring that one to maybe that kind 90%, so that you have something close. I think that's the better system. That's like the talk of maybe generalization and being robust and all this kind of stuff. I think we are going to talk. We are still going to talk about that. We call it variance bias trade-off. You trade off between variance and bias and stuff like that.
Yeah, and there are some performance metrics used to determine the generalization ability and the precision of the model in terms of new. And sometimes, like almost all the time, when training a machine learning model, or when applying a machine learning model, you usually segment or divide the data into training, test, and validation in order to test the
Evaluate it.
generalization ability.
Yeah.
Yeah.
I think those ones, but I think maybe we should just put those ones like we should just try and get the concepts now. Then maybe when we do, like you mentioned earlier, like the programming session, we can actually like talk about the reason why we are splitting data, why we are doing this, why we are this. We can see just reasons.
And probably if you have question on how 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 you can check, usually there are metrics that they have already been developed, so you can check all this data. That is for anybody that is wondering how you do it.
Yeah, in case of like question, even though we don't, we have not yet approached the topic. If someone raises a question, I think we can.
We can say
someone.
One. Talk about this. Then we talk. Okay, there is instance-based versus model-based learning. I think this instance-based learning, we've talked about this actually. Instance-based learning is like.
Shamu.
Yeah.
I get one question.
Yeah. Shoot.
These models.
Yeah.
Like I'm always like. Sometimes I feel like I understand it. Then when I hear something different, then it confuses me completely. Like a model now, AI model, right?
Yeah.
How will you? Is it different or the same? Like let's say like a normal function. Let's say in Python, let's say like normal function like this.
Yeah.
Is a model somehow like that, or how is it different from a function? Let's say a normal.
Okay,
yeah.
a model is a function. Actually,
Okay.
what function does is like you define your function, then you put everything what you want that function to do, you put it inside it. A model is also like a function. It's also a function. Like you define your model, then all the stuff you want your model to do, you put it inside it. So once you call that model, you can actually call a model like maybe like example in MATLAB. Actually, I think most of their models, you just write it. Maybe adaptables, you put your training data, like the expected arguments you are supposed to. Once you put it inside, the model will run the entire algorithm you've written. It's going to run everything, perform all the processes you've program the model to do, then return your output for you.
Another thing is it's very important for you to separate the concepts. There are programming concepts which are different, and the AI concepts of like algorithm and the mathematical aspect of it. So for the implementation, so how we do it is you separate it, implementation and theory. Do you understand, Faisal? So the implementation of the programming, it is very important for you to separate the concepts. So function in programming is not exactly like function in mathematics, even though they are relationships. I don't know whether you get it. So the implementation of the code is another thing that is in a way separate. They are concepts of programming which is somehow different. Kagani?
Okay.
Yeah.
But the most important thing is like function bar, it takes in inputs, then give you outputs.
Yeah.
Model system, if you provide it, the model machine learning system now, what you need is like you have that input, provide it with the necessary inputs, is going to generate output for you. So, but all these functions you see, like maybe you can write a function to like multiply two numbers together and all this kind of stuff. Those are just like simple this thing. But machine learning system, they are like you can write like 1,000 lines of code and stuff like that. The system will run, the machine learning system will.
Okay, so if I can understand, if I understood everything that everyone said, like the AI models, right? You can call them function, but the way they implement, the implementation is kind of like different from, like the process it takes is different from, like, let's say a normal programming function or maybe a mathematical functions, something like that.
Yeah, kind of. Yeah.
Okay.
So
not quite. A function, it just maps, right? Remember, follow map. It just maps. You just have a function is just a mapping relationship, a relationship that maps from just say you have two buckets. You have how do I put it? Okay, yeah, you have peeled. You have two buckets. On the right, you have fresh mangoes. On the left, you have peeled mangoes. So the mango from the right to left, the function is peeling. Is a peeling function. So it just peels. It takes the fresh mango, it peels it and puts on the basket, inside the basket.
Yeah, right.
So the relationship now between the right and left baskets is peeling. You just peel.
Yes.
So you see, this is simple.
Yeah.
So now, when it comes to like machine learning, you are learning. You're not just. It's not just a simple one-to-one mapping that you're doing. You are creating relationships between the first basket and the second basket over so many mangoes, both on peel and on unpeeled.
Okay.
Yeah. So basically.
Yeah.
Okay, nice. Okay. Thanks.
Yeah, is that. But once you train the system, once you train the system, so just like Ali explained now, that's like the distance you are doing it like over so many data points. But once you build a system now, its function will be to map. When you get new input, it's going to map input to a particular output. So after training the system, it will just serve like a function because it will be mapping your new input to that output based on what it has learned over like the numerous data sets you've trained it with.
Let me add, sorry. If you say y is equal to x squared.
Yeah.
So we are picking every x and squaring it and then putting it inside y.
Yeah.
You pick an x, you square it, you put inside. So you have defined the rule by yourself that y is equal to x squared.
Yes, yes.
You are the one who defined the rule now. In machine learning, it learns all the relationships and builds the rule by itself.
Wow. Yeah.
Yeah.
Yeah, then if we move on to instance-based model and instance-based and model-based. Instance-based example is this. We have like a system, a machine learning algorithm we call like there's what we call k nearest neighbor. What k nearest neighbor does is like you can like let's say our data points now when you are training this thing. What the system does is it's going to store your data points now. If you have a data point containing triangle, square, and let's say, okay, in this case now we have triangle and square. That's your training instances. These are your instances. Instance means actually data points, just a single data point now. So now you have this now. If you now collect new system now, if you collect new data, sorry, if you bring it now, is what the model does is now is going to compare like k nearest neighbor. You actually have to specify a number, like how many neighbors do you want to have? Like maybe
K,
that's specifically K. So now what the data points, what the system will do is going to take your new data point. Let's say this is the new data point. It's now going to compare it with all the data points you have in its neighbor. All the training data points. No, not its neighbor actually. It's going to compare it with all the data points you have because it's not going to know its neighbor. That's comparing it with all the data points is how it gets to know which one is its neighbor. It's its nearest neighbor.
Yes.
So now, if it's going to compare this, we compare with this, compare with this, compare with all the data points you have here. So now, based on the value now, we normally use Euclidean distance, like the distance between them. So now, based on this now, if you specify K to be 5 now, it's now going to choose. After comparing them, you get your values now. Maybe the distance between this one is 2, the distance between this point and this one is 3. Compared to this one is like maybe 10, compared to this one. You are now going to sort them like based on their distances. Which one are the closest? If you put 5, that's where the K in K nearest neighbor comes. If you specify this, it's now going to compare with the 5 nearest neighbors it has. So now, if you choose 5 now, 1, 2, 3, 4, 5. Let's say this 5, they are its nearest neighbor. It's now going to take this data point now and compare them. Now, in this K nearest neighbor now, you've chosen 5. This 5 happen to be like the 5 closest. Now, which one appear most for this stuff? You see, like maybe, okay, like in this thing, in this example now, I think they label this one as square. Now, if triangle wins, this new data points you have now is going to label it as a triangle. It's going to return it for you. Like this is a triangle. This new data point you put is a triangle. But if a square wins now, like if you have 3 squares and 2 triangles out of the 5 neighbors, then it's going to label that data point as. But and the K bar, they choose it as what to be an odd distance so that you don't have like a draw, maybe 3, 3, 4, 4, and all this stuff.
You always have one that is more.
Yeah, one. You always have one that is more.
So, and you see this concept. You see this concept like this KNN, KNN neighbors, decision trees. You know, these are the like the main. All, I think most of the subsequent ones are built based on these ones. And I was listening to one opinion by I think Andrew. You know Andrew now.
Andrew.
He was saying that people jump some of these things, and even though these fundamentals like KNN, like decision trees, these models can actually solve many of these issues that people are jumping and using.
I think so. That's another important thing about this thing. Like simple models, all these simple models, like KNRS neighbor, what it does is just compare all this stuff. It can actually do a great job. Then if you have a simple system that can do your work this thing, you don't need to go for like very expensive system like that is computationally expensive, very complex, and all this kind of stuff. Simple. There's even one saying like they call it like Occam's razor. There's one thing like that. Like simple is way better. You don't have to make something. If you have a simple method that performs well, don't go for complex stuff. So this is an example of instance-based system where like you have a new data point, then you compare it. But in model-based, you actually generate like you have like a model, like you at the end of the day, you generate a function that will map your input to this. Like example, this decision boundary, like this one now is model based. Now this is an example. You generate like a decision boundary now. This is what we call decision boundary now. So any data points now that falls into this side now is going to categorize this as a triangle. Any ones that falls here is going to categorize it as a square. So now when you are training your system bar, you actually train it once. When you bring in new data, you don't make any comparison again. Unlike instance-based. In instance-based, you have to start making comparison again. But in model-based, you've already built this decision boundary. Any decision that it will just check, is this inside this? Is this inside this? This will be the only check is going to do. If it's inside this, you make prediction straight away. This one straight away. Because this is what you learn in your model-based. Maybe this function, it might be like this is a function of maybe y equals to x squared plus 3x plus 5x plus 6x and stuff like that. This is a model design. But in instance-based now, it's based on the comparison, the distances, and all this kind of stuff. And this is not the only example we have for all this thing for instance-based models. And this is not like this, just like they are just like examples. K nearest neighbor like is the easiest thing to one can easily wrap heads around.
Can I guess that this model-based learning, and the other one, the instance-based, I'm just guessing. I'm guessing that the instance-based will outperform model-based will usually outperform it.
No.
Okay.
Actually, okay. No, actually, because because the problem is that you can have like now, but this example is very, very easy now. You can have a new instance, you compare it, but there are times you have these data points, they are inside this place.
That's now, that is the real deal now. The decision boundary is more complex. It's not a regular shape like that.
That's the thing. But like this bar is because this is a 2D structure. You can have this, place it to higher dimension, to like maybe 3D with this thing. So if this in this kind of stuff now, like KNN now, we just compare the distance. In this model base now, it's not just going to be like this small decision boundary. This one is just a line. You can have you can have it like in higher dimension, that the curve can go maybe something like this from here to here.
Yes, more complex.
Yeah, it can capture all this thing.
So what I'm thinking is that it will be computationally less expensive, but less accurate
Okay.
compared to
Okay,
the
actually, I
instant-based.
think the problem is that
I'm just guessing,
for
though.
yeah, I get. But the problem is that for every prediction you want to make in instant based, you have to run this process.
That's what I'm saying now. So it's computationally
Yeah,
expensive, but
it's
more accurate.
expensive. It's expensive.
More
I
accurate.
know I won't say it's more accurate actually, because you have
It's okay. It's just a guess now. I don't know anything about it. Just a guess.
yeah, like there is no general rule for all this stuff. Like this system, KNN neighbor, KNRS neighbor, it depends on your data. It can outperform all these complex models on some data points.
Because look at, just imagine the everything now. Like you have one new instance, it compares, it goes through all the various I don't know, the training instances,
Yeah.
each of them, and then gets a neighbor before choosing. This one, you have something like a fixed boundary. Just my thinking, Sean.
It depends now. But okay, another thing is like now we are talking about like two this thing now. We can have like different categories. Let's say we have like 1,000 categories now.
Yes.
And you choose like maybe KNRS symbol now. If you have like this one, it's not just square and triangle now. Let's say we have circle, we have all those stuff now. And if you choose like maybe it's like 5 now, definitely that might not actually be the case. Like maybe the label, the correct label of that system might actually be out of the neighbors. The KNN chooses.
The same can happen with this one. This model will the same, exactly the same can happen.
Yeah, but at least it depends actually. That's why it depends, but it depends on your data set. Your data sets, on some data sets, the KNN will outperform this on some data sets. But generally, the model based, I think they are the even the state of the art, like the models. These ones, they are the KNN is they are simple. You just do comparison, all this stuff. So the models, they are the state of the art or this thing. You can learn like complex relationship. You can learn the pattern. You allow the system to learn the patterns in there. This thing.
We've not gotten to SVM, but I want to ask.
Okay, support vector machine. Well.
Yeah. Okay, let's go. It's okay.
This thing, I think. What do we have here? Okay, I think this is an example of a model-based this thing. Like this is an example of KN. We talked about this KNN, and all this entire stuff is example of model-based. You want to learn this relationship. This is a model. You want to learn this. I think this is a linear regression model. If I'm not this thing, this what you are learning. Yeah, model now. And the function of the model will be like this: your data points. All these points we have. All these. This is a scatter plot of your data points now. So the function of the in model based now, you want to learn theta naught and theta 1 now that we generate a good prediction for this.
How
your data.
How now you do what? How now?
Yeah, I did.
How now?
Fine.
Are we together?
Yeah.
No.
Haruna,
Haruna, are you sleeping?
Okay, everyone don't talk. Huh?
I'm not sleeping.
Yeah, I think that's like the model base. What you just in model base, you just want to like optimize the these parameters.
Shake don't come out.
Shake
there, boy.
Shake there.
Okay, shake.
Shake you Shake Nazikili.
Allah shake me. Now please go on.
So I think the model based, that's just actually it. But in model based, what's more this machine learning system? Like if you have something like this now, theta 1 plus, and if you have a function, you define a function like this, then what's the oh boy, what's happening? Can you guys see my screen?
It's blank. Pitch black.
My system is crashing. Okay, no. I think
go buy correct computer.
No,
Can't save money.
No mind my system. Money no day save me. So but I say shake day around. I think I saw his message, So like that's exactly what we do. Like we do all like optimization of this. If you define this for your model number, what we actually do is do optimization. Like an example, like if you choose this theta naught to be 10, you choose theta 1 to be this value now. This is the line you get. And from here now, you can see that this line does not actually fit this data. But if you choose this value and this value now, it fits the data. What the model does in the training of the system is going to maybe the first prediction, the first value it assigned to this theta naught is this value now. It's now going to modify it until you have this, or you have a line like this, a line that can actually fit the data well. So that's what the model is. You adjust all these parameters, all these theta naught, theta 1 is what we call parameters, and that's the values you adjust when training your data. And we have what we call hyperparameters. They are the values you assign to the model prior to training. Example, in k-nearest neighbor now, the k now is an hyperparameter because you don't adjust the value of k when you are training. So I think this is just an example of this thing. Upload sleeve. So this is like a package in this thing. They're just visualizing this thing. Visualizing. Okay, like this is a model, this thing. This is a linear regression model. We all know linear regression. So like, yeah.
Go back, you get one place like that. You get one. This SCI kit. I've been taking that for only pad though. Now pad them they use connect with that. What do you mean?
No, Scikit-Learn. Scikit-Learn is like a package. It's a library. It's a package actually. You have, it's a framework or package. You call it package. You call it listening. What they do is like they do with all, not all, but with machine learning models. They've built like this linear regression now. You can
They do computer
linear,
vision.
yeah, computer vision. No, I don't. They do. It's no computer vision. Is
I've used it before. Scikit-Learn.
Oh,
The Scikit image.
Yeah, Scikit image.
yeah.
Thank you.
I think they have different distinctions. They have different things. But this Scikit-Learn actually, I think the only this neural network model you have there is maybe all this MLP. There's MLP, multi-layer perceptron and all this stuff. So you can actually listen. But all this complex thing, like maybe recurrent neural network or all this stuff, they don't have this. What they just focus, they are just focusing on machine learning system. But the likes of them, like Keras is another package, TensorFlow. Then what they focus on deep learning models. But it's not like them. They have like all this linear regression and all this stuff. They have it there because linear regression itself, you can build it like a neural network. It's just like
the good thing is you can use all of them at the same time.
Yeah, you can use all of them, but all they have like their limitations. Like you can't go beyond this, and there are other different packages like independencies like that you can actually use with them and do complex stuff. Just like something like maybe all these add-ons and or be easy add-ins and this, you can just something like this, but it's not like adding but it's just another package entirely. But you can that's the beauty of this thing. Someone can create the package, then you can use it. So far you know how the package with this thing, you can use it. Just like this matplotlib now is actually used for visualization. This numpy is for numerical computation. Numerical Python, that's the menu of the Python, but it's used for numerical computation. Maybe if you want to do like all this, any mathematical
NumPy is very powerful.
Yeah, it's very powerful. Even pandas now is used in like manipulating your data frame. You do all this stuff. You use in manipulating data. The Scikit-Learn, the machine learning framework is a machine learning framework. You can get all this stuff. So like example, if you check somewhere around here now, I think this PD, you import pandas as PD. They import this pandas now is what they use to read in the data set. The name of the data set is this structure. So though actually they define one route, they use the pandas to read in the data set. Then they come here and use plt.axis, plt.show. They use it in visualizing the data. Then they come here now.
Let's run it, Shawn.
I don't think we can't actually run it. I have not actually checked this thing. I don't have this thing.
Check now. Check. You have the website down. You can download the data.
Yeah, they give you. You can use the website.
We talked about this the other time now.
You can use the website.
Yeah. I've not
It's
actually
GitHub, so
checked
you
it.
can use the
I'm
website.
not. Yeah, the GitHub. There's GitHub, but I still have to clone this thing and put it on the system and stuff like that. And I've not actually done that.
Maybe next time. Sisters, no.
My
Which
bad.
app will be
Next time, please. Sorry for not.
Yeah, next
No,
time.
we will not take any sorry. We told you last time.
Sorry, guys. Sorry, guys. Next time we do that.
Send Humba for group.
There's no sorry.
May we use our whole body.
I think I've closed this thing. I think I just closed the
book.
Wait, sorry. Let me just.
Send Humba. We use our whole body.
Now?
Send Humba. We use our whole body.
No, you know if you use Humba, you know if you send Humba for system now.
Which system? You know your group.
We know you can't send Humba on system now. Have you my phone no I don't think my phone is here. So that's just
your phone will be there, don't worry, very soon.
This linear regression, like linear regression model, is from Scikit-Learn. Then from Scikit-Learn, there is what this is k-nearest neighbor. The k-nearest neighbor we
have 8
about.
minutes.
We have k neighbors.
That was we did go, guys. It's from 1:30 to 3 go.
Yeah, 1:30 to 3.
We have 8 minutes.
Yeah, we have k neighbors and this thing. That's just this thing. And these are actually like in summary, these are the steps you do in this thing. You study the data. Like you actually first you actually have to get the problem, then understand your problem.
3:30, I think. 2 hours, go? Okay. 2 hours. That was what you said. Guys, please remind me.
Is it?
We said 1:30 to 3:30.
No, we said 3 o'clock actually.
1 hour 30 minutes.
Yeah.
Are you sure?
Because I think the last time we were finishing 2:30.
Huh?
So we made it 1 hour 30 minutes.
Oh, okay.
So you study your data, you select a model, you select your model now. You can have different models. You can use any.
We not study any data. We not select any model.
No, wait. I'm not saying like in summary, but like if you want to build a system, by a machine learning system, what you do is you understand your problem first. Then you study, you collect data. You collect your data. Like maybe say if I want to predict like ages of people now, like maybe in this society now, if I want to predict, maybe what do you think? What do you think like can give you like a rough like what can you look at in someone and think like, okay, maybe this person is 30 years old, this person is this thing. Maybe their appearance and all this kind of stuff.
Yes. Wrinkles.
Maybe, yeah, like wrinkles on their face.
Just weird thoughts here. Maybe if we can count the number of wrinkles on some people's faces.
Yeah, there are this thing now. They've researched, there was a research on that.
Seriously.
Like, they built like a system that can.
You stole my idea. You stole my idea.
No. They built like a system that can actually categorize people. That can actually predict people's age.
No, I mean to count
the wrinkles on people's face. Yeah, okay. I don't know. I don't know that. What will you do that for? Because your system has to add value to this thing. Because I don't think anyone will want to know like the wrinkles on the number of wrinkles on their face.
Don't worry, you will not understand my idea now. When I develop it, you come and visit my app.
We are now talking. Let's wait for that. You select a model, there are different models you can select, then you can actually select a model. You select a model, then you train your model. If you train your model, you evaluate it. You make predictions on new cases. This is like evaluation, you make inference. If your model is good, you can launch it. But if it's not good, you can come back.
Return.
You go back. It's like a machine learning system. It's like it's a cycle. You can go back. Maybe the model you select cannot actually. It's not good enough for your distance. You can go and choose another type of model. Then you do the training again. Or this, like in research, this thing, you go back to your model and select another model. Like, or maybe you go and choose some new parameters, some hyperparameters for your model and retrain the model. This like research this thing. But in this thing, like maybe in production this thing, you can go back to you can even go, maybe your model is good and your data, you did not maybe do some adjustment. If you do evaluation, you see like, okay,
This is not good. An example, okay, let me give an example of this evaluation, this thing. Like in image classification now, if you collect data, let's say you collect data now, maybe let's say we have the total data points we have is, let's say, 1,000. So you collect data, maybe we are using maybe Africa and Asia and this and let's say European now. You are collecting data from these three people now. Then you collect maybe out of 1,000 this time, you have maybe 500 on African people, you have 400 on the Asian, then you have 100 on the European. You build your model based on these data points and your this and that. When you build your system and it performs well on your training data now. It performs well on your training data. When you evaluate it on new data, you see that when you get an European an European data you put it there, but your model is not doing good. In the evaluation process, you do error analysis. You now go back, you say, okay, actually my system is not, maybe the overall accuracy, is good, like it's good. But if you do error analysis, you can see that from the error analysis you do, you can see that, okay, most of the predictions my model goes wrong is actually from the European people. You now go back to the European data sets, like the data points you have there, what's wrong? Maybe the image is not clear enough and all this kind of stuff. So you can go to the data point and change the data point, tune the data point to get a good data point, like a good quality data, and kind of stuff like that. Or you can add more data points to that. You can do like augmentation and stuff like that. So that's once you get your design. That's in short, you can go back to data, make adjustment to the data and retrain your model and before to get a better performing model. Or you can go back to a model and select a better model to get a better performing this thing. I think that's all about this chapter. So okay. Oh no, that's not all. Main challenges of machine learning. There are some challenges. It's already verified, like insufficient quantity of data. At times you might not have enough data to train your system. This one, the challenges we face in machine learning.
Can we start from the challenges of?
Okay, yeah, in our next session. Yeah, I think this is
Guys,
you can stop here.
Yeah, please talk if you still have 2 minutes. If you want to comment, or suggest or something. Yeah, I wanted to say that can we shift this to Saturday? Because, for example, I'll give an example of why. The lady was supposed to be here, but he's in church now. You know, so and I also have a commitment every Sundays from 1:30. So I think our initial schedule was even Saturday. Oh, we shifted it for some reason, I think. So is Saturday okay? Or should we make it during the week? Or is weekend okay?
Well, I'm good with either date.
Saturday
is okay for me.
Saturday is fine.
Saturday, what?
Kenneth, is Saturday okay for you? Kenneth.
Yes, Kenneth.
Saturday is okay for me.
Okay.
Wiki Ogasa.
We can do it on Friday.
How about Anadas?
Hashim.
Okay,
On
share
Friday.
your aquarium like it.
How about Anadas?
Now Hashim be this, I mean who?
Hashim.
Who be this one? Who be the second to last before Ken?
Yeah. Okay.
Oh, now there.
We had this book here to kind of Chinese one. No sooner emu.
Okay, Saturday is okay, man.
It's okay, huh?
Friday.
At least our names now. Our names. No,
Hashim know that maybe Hashim too na AI guy. I think saying the group. And
Is any weekday okay? Sheikh Moy is saying it's not convenient for him.
Yeah, Friday, Saturday.
Is any
What is wrong with Saturday?
Yeah, someone is saying Saturday might not be convenient for you.
Hey, Sheikh.
Is any weekday okay?
Friday.
Friday we will not have this time here. We have to change the time.
What's the bottom?
Understand?
Thursday, yes.
Thursday okay for everybody.
When?
Thursday. Oh, Roji, Thursday kace ko?
Yeah, Thursday.
Yeah,
Monday.
Really, like,
Monday.
Like,
Now?
I don't have any classes now, so any day I think it will be okay. The main problem is just the time.
Okay,
Because
Monday.
routine and sleep.
2 to 4. 2 to
Yoshi.
4.
On Friday.
On the
Friday
now
too.
Friday, Friday. Yeah.
What time? Is Monday? Wait, so that's Monday.
On Monday, no.
No, norms. I'm at time. How about the time? What time?
Kasan za a fara canza lokacin da asa.
2. I saw 2.
1:30 ba?
Okay.
Yawanci around 1 to 2 ina da dan nima ina da dan wani kaman class aka 1 to 2.
Ka gane a bar abun nan a weekend da yafi.
Okay.
You guys are speaking vernacular.
Sorry.
Oh.
Okay.
Sorry, sir.
Don't worry, all up on everybody is like,
We should.
the police will so arrest all of us.
Saturday works for the majority.
Yeah, I believe so.
Saturday weekend.
Okay.
We'll record the class so that person who is not available can just check. We're always recording. So, well, I think Saturday works for the majority. So, 1:30 time. We need to change time.
That's why I'm asking whether we'll be using the same time.
If we change time, we'll change it again, no? Because that change the location last.
Yeah, okay, so let's just leave it here.
Or let's change it from afternoon to another time. Morning or evening.
Afternoon is okay.
The afternoon is okay because morning,
I don't think morning is a good thing.
I think this time is better.
Afternoon is better.
So
1 to 3 for 2 to 4.
2 to 4.
Ko 2 to 4 ko 1:30 to 3 yadda ake yi in normal ne.
Let's do the 2 to 4, correct?
2 to 4, okay.
Yeah.
So for now, 2 to 4. For now, because it's for now. Very soon to change.
I mean, this one was like 1 hour.
2 hours.
2 to 4, go?
2 to 4.
If you do 1 hour, 30 minutes discussion.
So 2 to 4.
Yeah.
Ahmed, is 2 to 4 okay for you?
Yeah, it's okay now.
Okay, sir. Okay, sir.
So what's the conclusion?
I'm thinking that this 2 hours is too much.
Too much?
Yeah. 1 hour, 30 minutes is okay.
Okay, 2 to 3:30.
3:30.
1:30 to 3.
Okay.
Yeah, I think that's good because at times
3:30,
prayer time changes, man. So
can we just leave it to this 1:30 to 3?
Listen.
Yeah, it's okay. It's okay.
It's okay for me.
It's fine.
1:30 to 3. Just as we did today. So guys, 我先把这个结束，好不好？
Okay. let's be guided. Don't be all of us go pass the Scikit through.
I don't carry you go away, no.
No be all of us go pass the Scikit through.
But wait, how far this HSK matter? Roji for na side two na the same thing.
How?
Now let's see one of you talk. Say na Ogashi and in Kabal. Na them.
Dan Allah, kai.
Kaka kira mana ruwa